Hey everyone, my name is Dave Johnston and I am the director of the Duke Marine Robotics Remote Sensing Lab. And today I want to talk a little bit about drone platforms and cover a little bit about the kinds of platforms that are out there and why you might want to use them. So for this video lecture, I want you to be able to identify the difference between fixed wing and multi-rotor drones, describe how energy flows through them and how information flows through them, and outline some pretty basic pros and cons of those different systems, because they're going to be useful for different kinds of things at different times. And so these are the things that I'm hoping that you'll be able to get out of the lecture that you're going to look at today. To start off, we can think about these drone platforms as being a combination of the actual aircraft and a controller. And I'm not going to talk much about the controllers in this case, but instead talk more about the actual drone itself, the different components that most drones are comprised of, and how they function, okay? And so for the next 8 minutes or so, I'm going to take you through both fixed wing and multi-rotor drones, talk about the different components, and kind of get you familiar with them. So first of all, let's talk about our multi-rotor drones. And so these are aircraft that have more than one propeller. They tend to be, sort of in a helicopter with multi-propeller type formats. And they tend to have a central part of a fuselage where a lot of the electronics are contained, as well as 4 booms that extend out that essentially support the propellers. And they usually have legs underneath them that tend to keep the main fuselage of the aircraft up above the ground so that the sensor that might be below it is not touching the ground, okay? And if we now sort of switch that view and take a look at this aircraft from the top down, you can see that those 4 booms are spread out and that the propellers here in black and in orange are actually set up in a counter-rotating format that helps the aircraft resist the forces of torque that are created while those propellers are spinning. And that allows the aircraft to be able to do that, but also rotate and pitch, yaw and roll, and all the other things that are needed to make that aircraft fly the way you want it to. I want to zoom in now a little bit on the electronics and take you through the things that are important. Motors are clearly important, and those motors on the ends of those booms are controlled by electronic speed controllers that take the power from the battery and the information from the flight controller and tell them how fast they should spin. That centralized flight controller controls all of the electronics, including the sensors that may be used. And it's controlled by signals that you send with your transmitter to a radio receiver that's integrated into the aircraft system. If it has a camera, it will often have a gimbal that will allow you to pan and tilt the camera, which is important. And finally, the aircraft knows where it is because it has a GPS module, okay? And so these are pretty common components that are going to be found across the drones that you may be using for your marine science and conservation missions. So now let's contrast that to maybe what might be a bit simpler aircraft, and in this case, a delta wing fixed wing aircraft. And you can see in this case, it has a camera system as well, has a central fuselage, and has 2 wings that have control surfaces called elevons that help control its pitch, yaw, and roll. In this case, it only has a single motor, which means it uses less power, might be more efficient, and a little bit quieter. And it also only has 2 servos that control how those control surfaces function. And so in many ways, this can be thought of as a simpler type of aircraft. And these fixed wing aircraft tend to be a little bit more efficient, can fly for longer periods of time, and may be best applied for things like survey missions when you're trying to do habitat or maybe count animals that don't move very much. All right, so now we can take that back into a schematic that shows all those components. And in this case, we're looking at an aircraft that has a set of different control surfaces that are green, blue, and orange, and purple, controlled by multiple servos, so it's a bit more of a complex aircraft, but it has a single motor and a series of antennae for controlling the aircraft, and also a GPS sensor. And as we sort of back out now and take a look at all of these systems, you can see that the schematic has power flow in black and red from the main battery, and the yellow lines indicate information flow. Okay, and so if we start to trace these pathways, you'll see how power flows to them and how information flows. So first of all, here's our battery. You can see those black and red leads coming out of that are providing power to all the different components of the aircraft, and clearly going directly to motors, which are also controlled by our electronic speed controllers, which are labeled just below that. The rest of the equipment that's on the drone may run at a lower voltage, and so you'll often have in drones something called a battery elimination circuit that actually reduces the voltage that then goes out to control the other components. And so you'll see here that power then gets distributed out information gets distributed out from a flight controller that's seen from the top down there, connected to a GPS. And just below that, you can see the outputs, and they are sending information and power out to the servos, which are controlling the control surfaces that help the airplane orient itself in its attitude. And they also send information out and power it out and receive information from a pitot tube, which is assessing the airspeed of the aircraft at any given time, which is important for navigation. It also has a receiver to take inputs from the controller on the ground of the pilot. And it will also have usually a camera attached to it, and sometimes more than one camera depending on the system that you are using, maybe one for navigation and one for science data collection. So those are sort of the similar components, sort of fixed wing in comparison to our multi-rotor that I talked a little bit earlier. Okay, so nice schematic to give you an idea about how that works. The last thing I want to do is just briefly introduce you to a different sort of system that combines both, and we refer to these as transitional aircraft. And so this is a mock-up of a fixed wing aircraft that actually can hover. So it has motors that make it take off vertically, and then it transforms into horizontal flight to be able to fly longer endurance missions. Okay, so that's a quick introduction to drone platforms. I hope you're able to identify the different components of both multi-rotor and fixed wing aircraft. You can clearly see now how energy and information flows through those drones, and hopefully you'll be able to outline the pros and cons of those different systems to be able to apply to your particular missions. Thanks for watching. See you soon.